So this video is going to be looking at continuation of introducing acid base. And so this is following the notes that have been given to you. So this is going to be the background to what I call pH calculations. So it is what we call the self-ionization of water, self-ionization of water. And if you want another resource is section 5 of chapter 14 on your online book is where they talk about this. So water, again, as we've been talking about, is just so unique. It has so many unique characteristics to it. And what happens is when two water molecules get together occasionally, they end up making two different ions. One is the hydronium ion and one is the hydroxide ion. But this is only when, again, two water molecules get together. It doesn't happen often, but it does happen occasionally. In your book and on worksheets, you will also see the following: water breaking up into H plus and OH minus. The one that I highlighted here is more correct, meaning water can't just, one molecule water can't just break up into its two ions. You actually need the interaction of two water molecules at least to kind of get there to ionize. So again, for shorthand, you can write this equation, but just understand in a real sense, you can't have that happen. So acids are always going to be considered, again, H plus or hydronium ion. Bases are going to be OH minus. So if we are neutral, what that means is you are not acidic and you're not basic. It has nothing to do with a pH of 7, okay? So please cross that out in your notes. So it has to do with equal amounts of H plus and OH minus. You can write neutral as H plus is equal to OH minus in brackets. That is really the definition of neutral, not pH is 7, because pH is going to depend on other things. So we are going to say that it is equal amounts of H plus and OH minus. So again, when we put things in brackets, it just means concentration. So again, molarity. Okay, so molarity is what we use for concentration for all of this. All right, so in order for you to understand where we're going with this, I'm going to flip essentially the more simplified reaction. H plus plus OH becomes water. So if I take these two and write them as concentrations, if I multiply them, I get the concentration of water. So if I take both of these, there is a magical number that scientists figured out, 1 times 10 to the negative 14th, called the Kw. It is the ion product constant for water. What you need to know is that it's 10 to the negative 14th. 10 to the negative 14th is going to be a number we're going to use in a series of different calculations. So when these two concentrations of the hydrogen and the hydroxide ions are multiplied, you always get the same number, 1 times negative 14th. So it is a constant. So please understand, constants mean they don't change. So this will not change unless you change temperature, which we're not even going to talk about. So if I go back to my definition of neutral, H plus plus OH minus are going to be equal. That is my definition of neutral. What if that's the case? I could then substitute in for this equation another H to make it the same variable, essentially, because OH and that are the same. So that's H times H gives me water 10 to the negative 14th. So that's H hydrogen ion squared, 10 to the negative 14th. That means hydrogen at neutral is 10 to the negative 7. That is the concentration. So this is molarity of H plus at neutrality. This is where we get the pH of 7, okay? Because that is a very tiny, tiny number. Well, we don't like tiny numbers and we don't like big numbers. So we need to convert that. And that is what we're going to be talking about next, okay? But that is how we define neutral, okay? Since that number is so small, 0.0000001, we don't like small numbers. So we're going to find a way to kind of fix that, All right, so in general, acidic means you have more H plus than OH. So this is the dominant. And then basic OH is a stronger amount in the solution. So because these numbers that we're dealing with are so tiny, 10 to the negative 7th and small numbers like that, we're going to do something called pH. And pH is going to be the negative log of hydrogen ion concentration. And all the lowercase p stands for is log, okay? So we're just gonna plug things in our calculator. We're not gonna do anything besides that. So if I were to take a look at 10 to the negative 7th, and I put it in my calculator, negative log 1 times negative 7th, the log gets rid of that power of 10, and you get a pH of 7. That is why a lot of people are like, oh, pH of 7 is neutral, only at 25 degrees Celsius. That is where it's a little bit different. So all we're doing with these calculations is taking the negative log of different numbers. So 10 to the negative 6th, if I have a hydrogen ion concentration of that, my pH, all I got to do is take the negative log of that number and I get a pH of 6. I know that this is acidic because pH of 6 is going to be something we talk about. We also have OH, so we could also do concentrations with OH. So I could do the negative log of OH concentration. That's called the POH, P just standing for log. So if I have an OH concentration, 10 to the negative 5th, if I take the negative log of it, I get a 5, and that is POH. Well, if we wanted to convert that to pH, there is another formula that's going to be very helpful, and that is pH plus POH always equals 14. So that's going to be another formula that's going to be very useful. Where does that come from? Well, the KW is 10 to the negative 14. If I take the negative log of 10 to the negative 14, I get 14. Well, pH plus my POH will always equal 14, so I could easily find the pH that way. So in the next video, I'm going to go through a couple of different other calculations to kind of give you practice. That's the background information of where pH came from.